Bismillahirrahmanirrahim. We have done HSRP lab in Packet Racer. Yesterday we did VRRP lab in GNS. Okay, and today again we'll do the lab GLBP lab actually in GNS. Okay, so let's see how we can configure it. And if you remember, when we were explaining the FHRP protocols, we discussed that GLBP is actually the one which gives us the facility of load balancing. That was the only thing which we discussed that is the best of all. And GLBP is a Cisco proprietary. Okay, it's a Cisco protocol and only works on Cisco devices. Okay, so why it's different from HSRP and VRRP? Though the difference was that we have load balancing first and the most important thing. Then we don't have the concept of master and backup. We don't have the concept of active and standby. Okay, we have the concept of AVG and AVF. Okay, AVG is active virtual gateway. Okay, and AVF is active virtual forwarder. Okay, forwarder. In topology, we are going to select one AVG. Okay, AVG will be the one who will be responsible to assign virtual MAC addresses to the clients. Okay, it means if I have 5 different routers, gateways, one of it will be AVG. The AVG is going to save the virtual MAC addresses of all these 5 routers, and then whenever a PC is sending ARP request, okay, to the AVG that I want to go outside to the internet, okay, so that AVG is going to assign one router that this is your gateway, this is your AVF, okay, active virtual forwarder. Okay, so it means in one topology we have one AVG and we may have several AVFs. Okay, and only one virtual IP will be used. Only one virtual IP will be used, but one virtual IP with multiple virtual MAC addresses. Got it? One virtual IP for multiple virtual MAC addresses. For every router there will be a virtual MAC address. Okay, and those multiple MAC addresses will work with only one virtual IP. Okay, so let's see. I'm gonna drag this and 2, 3, 4. And let's say this is our ISP side. In between we need a switch to connect these devices. Here switch is only used for connectivity purpose, no configurations can be done on it. Okay, let's take the cable, fast Ethernet 0x0, connect that to first interface, fast Ethernet 0x0, connect that to second available interface, 0x0, connect that to third available interface, and so on. 0x0 serial, connect that to 0x0. Let's say 0x1 is connected to 0x1, and 0x2 is connected to 2x2, 0x2, serial to 0x2. Okay, now actually these routers are going to be my gateways. Okay, all these 3 routers. So I'm just gonna give some kind of circle which identifies that this is going to be, right click on it and say style and fill color I want to give let's say yellow. Okay, apply, bring it here. This 3 routers are going to be my right click and lower on one layer, so you can see your cables, everything. So these 3 routers are going to be my gateways. Label everything. I'm gonna use 192.168.1.0/24. I'm gonna use 1.0.0.0/8 here. I'm gonna use 2.0.0.0/8, and I'm gonna use here on this link 3.0.0.0/8, and on this side of the router, let's say suppose we have 10.0.0/8 network here. Fast Ethernet 0/0 on this side. Okay, let's consider that we have some network there, and let's label that this guy is going to be our PC. Okay, we'll configure it in a way that it's gonna work like a PC. Okay, because we have PCs here in GNS, but you can assign IPs. It's just for virtual topology, just to show virtually it doesn't work. Okay, you really can configure it. Okay, so that's why I'm not gonna use it. I'm just gonna use this router as a PC, because we know router is actually like a PC. Okay, so yeah, virtual IP which I'm gonna give to these is going to be 192.168.1.254, and that's all. Okay, it's PC, and here it's gonna be my ISP. This is going to be my ISP, and now you can do another thing just to make it look good. You can right click and style, give it some color, fill with color, this one. Okay, so this is my PC, and click on it and right click, duplicate, click and bring it here. So one is my PC, one is my ISP. Okay, let's start all the devices. So all here will be green. Okay, first I started all, then I have to click on labels to see the labels of each port you have connected. Okay, and finally click on console, connect to all devices. So it's gonna start all these PCs. Router 2 is actually going to be my first router I'm gonna configure. Okay, so I'm gonna do it very fast because I've done this before. Conf-T interface, what interface I'm using here, Fast Ethernet interface, Fast Ethernet 0/0, and IP address is going to be 192.168.1.1, 255.255.255.0, enter, no shut. Interface serial 0/0, serial 0/0, and its IP is going to be, IP address is going to be 1.0.0.0.1.255.0.0.0, no shut. Okay, this is done, and these two are done. So I need what? I need here exit router OSPF1, okay, and say network 0.0.0.0 and 255.255.255.255, enter, sorry, area 0, enter, and That's all I need to do here. WR. So first is done. Now router 3 conf T interface FA0 by 0, IP address is going to be 192.168.1.2.255.255.255.0, enter no shut. Okay, interface serial 0 by 1, yeah, 0 by 1, 0 by 1. IP address is going to be 2.0.0.1.255.0.0.0, enter no shut. Okay, and exit from here. Router OSPF1 network 0.0.0.0.255.255.255.255. Enter, sorry, area 0, enter, and WR. This is done. The last one is going to be our router 4. Router 4 conf T interface FA0 by 0, IP address is going to be 192.168.1.3. Okay, 1, 2, and last one is 3, 255.255.255.0, and no shut, and interface serial what? Serial 0 by 2. 0 by 2. You see here, serial 0 by 2. Okay, connected. So I need to give IP to this, and IP address is going to be 3.0.0.1.255.255.0.0.0, and no shut. Okay, and exit from here and say router OSPF1 and network 0.0.0.255.255.255.255 area 0, enter, and W. Okay, so third router is done. Now ISP router 5. Router 5, this one conf T, first one interface serial 0 by 0 is IP address is 1.0.0.2.255.0.0.0, no shut. Okay, then interface serial 0 by 1, and IP address is going to be 2.0.0.1, sorry, did I give, yeah, 2.255.0.0.0, enter, no shut. Again, interface serial 0 by 2, IP address is going to be 3.0.0.2.255.0.0.0, enter, no shut, and exit from here and say router OSPF1 network 0.0.0.0.255.255.255.255 area 0, enter. Okay, this is done. Adjacencies are created. Now if I say do show IP interface brief, so for local area, let's consider that my fast Ethernet 0 by 0 is connected to this 10 network. Okay, let's consider, so I'm going to give IP to this interface. Okay, so interface, sorry, exit, interface FA0 by 0, IP address is 10.0.0.1.255.255.0.0.0, and no shut. Okay, so this is all done. With router 1, we can do the same technique which we did in yesterday's class, that we will make a default static route, okay, to the gateway, to the virtual gateway. But we can do another thing also. We will turn off the routing on this router, and show it the default gateway, configure default gateway. How? Let's go to the router 1. Let's see. I'm gonna say conf t and say no IP routing. No IP routing will off the routing uh, facilities on these routers. It will not be able to route. Okay, it will work like a PC then. Okay, and then say IP default gateway. Default gateway is going to be 192.168.1.254, which is going to be the virtual IP. I haven't done GLBP till now. Okay, so but I'm just fixing it for getting it ready for. Okay, and don't forget to assign IP to this interface also. This router has no IP till now. Okay, so conf t interface FA0 by 0 and say IP address is going to be 192.168.1.100, let's say 255.255.255.0, no shit. Okay, so this is all done. Now to make it good, we have to write here GLBP gateway load balancing protocol. Okay, configuration. Okay, so this is here. Let's start from router 2. Okay, they are quite similar. I told you yesterday that I want to do it on that spot, but you said no. So let's see. Most of the things are similar. Conf t interface FA0 by 0, same, enter to that interface. Okay, so I'm on this interface now. Okay, this interface. First command, when I was configuring HSRP, I used to write here HSRP. Standby. Okay, when I was doing VRRP, I told you that we write VRRP here. But now if I'm doing GLBP, so I have to write GLBP. Simple. But you can see it's giving us a lot of group numbers. Okay, you can make a lot of groups here. It has more group because it was made in 2005. Okay, and 6 years later than VRRP, so it was more advanced. It has more advanced features, okay, than the previous two. So for one thing, that it supports more groups. Okay, you can create more groups in this. So let's say my group is group number 1. Same things, IP is there, but this is the new thing. Load balancing is the new thing here. Okay, preempt is there, priority is there, timer and waiting. They are even now the part of CCNP track. Okay, it's on CCAE level. You can discuss these waiting and these things. So what I'm interested here is that IP, create your virtual IP 192.168.1.254 first. It's going to be the virtual IP. Enter. Second, GLBP 1, and I'm telling that priority. Now this priority doesn't mean that this guy is going to be active or it's gonna be master or something, because in GLBP we have the concept of AVG and AVF. I'm telling you again and again. So if a router has more priority or higher priority, will become AVG, active virtual gateway, which will be responsible for distributing the virtual MAC addresses to the clients. Okay, so let's say 150. No, let's say 200. Okay, by default it's 100. Enter. So if its value is high, so it means it will be the AVG. Okay, and still the terms will be used. If you see show GLBP, still the term active will be used for that. Although it will be AVG, but it doesn't show you there that this is AVG. It will show you active. And the AVF will be shown again with standby term, standby, and the other one is going to be in listening state, okay. So let's see. GLBP 1 preempt. What was the preempt command? Do you remember? What was the purpose of preempt command?
Reload to make it active.
Very nice. If the AVG is not available, the AVF will become AVG. AVG comes online again, so forcefully it's gonna take its power again that I am AVG because my priority is higher. That is preempt command. Enter. Okay, one more command, GLBP 1 put question mark timers. You see, you can set hello interval time, okay, between this group, okay, clients or partners. After how much they should send hellos to each other. What will be the dead interval time? So you can set that here. I don't want to give in seconds. I can give 1, put question mark, then dead time, whole time, let's say 5 seconds. I can say that, but no, 1 second is too much if I think. So I say that I want to give in microseconds. Microseconds, let's say 100 microseconds, and then put question mark again. Dead interval time is or hold down time is going to be microseconds, let's say 500. It's very less, okay. So they're gonna send hellos in these dead interval. It's gonna be very fast, okay. They're gonna respond very fast to each other.
And this won't affect on network speed?
No, not at all. On low, because this is on your, you see, no, because these are on your local area network side, okay. You're connected to your gateways or connected to the internet. You are on your local area network side, and on local area network side we don't have bandwidth issues, okay, because we have every link is going to give us 100 megabits per speed, okay. So it's too much. We don't have bandwidth issue, we don't have that problem here. So the less time you give, it's good, okay, no issue with that. So that's fine. Okay, one more command, GLBP 1 question mark and load balancing. Now load balancing can be in 3 different ways. How? If I put question mark, you see host dependent, round robin, and weighted, okay. Now just see what each of them means. You see, host dependent means load balance equally, source MAC determines forwarder choice. Host dependent means that once a client is given one virtual MAC address, that virtual MAC address will be used only by that client only, even if that client is not available or it goes offline or any problem, still that MAC address is going to wait for this client, not any other else, okay. That is one. Round robin is the one which is normally used. It means if one MAC address is available, router 1, AVG assigns that to a client. Now due to some problem, that client is not available and this virtual MAC address is free, so AVG can assign that to some other client, okay. So round robin mean that they can be assigned multiple to different clients, not to one, okay. It's not sticky to one client, or it's not just for one client. It can be assigned, if it is free, it can be assigned to different clients. And
can they assign the IP or MAC address? Assign what?
No, virtual MAC address. Assign virtual MAC address mean you see the PC for the first time is looking for the gateway MAC address, right? The broadcast is received by the AVG, okay? It says, oh, he's looking for gateway, and I have the list of all virtual MAC addresses, okay, of my group, okay? So it's gonna tell the client that, okay, use this MAC address, which is of R1, use this MAC address to go to the internet as a gateway. So the client is going to save that MAC address in its R cache, okay? It's going to save that in its R cache, and whenever it's communicating, it's going to use that information, that MAC address of that router. Okay, so I'm gonna use round robin. Okay, it means not specific. Weighted is load balancing proportion to forwarding weighting. In weighting there are some other options. Okay, again it's you're even not the part of you see not here. If I tell you question mark, yes, weighting question mark, you see track is there. So it's again a very it's not even the part of CCNP track, okay? So don't need to go for that. But it's also a way of assigning virtual MAC addresses to the clients. So that's the only you can remember. Okay, track here can be used the same like which we used in HSRP and VRRP. Track meant that if the serial link is down, okay, some problem on that link or in any interface, so decrease the priority value by this value. So if it decreases that, so automatically the AVF, one of the AVF is going to become AVG, okay? So you can use that, but for now I'm gonna use what question mark, load balancing should be done how? Round robin, enter, and enter DR. This is done. Router number 3, let's do that. 3 very fast. Conf T, interface FA0 by 0 and GLBP 1 question mark, and IP of virtual IP should be same of all, okay? So 192.168.1.254, enter, and then GLBP 1, and priority of this is going to be, let's say that was 200, let's say it's 150. Still it's less than the AVG, but I want this guy to take over if the AVG is not available. This is AVF now. So if this guy, the AVG is not available, so I want this router to become AVG. Okay, so how it will, because that's why I give this priority value. GLBP 1 and say preempt.
Put it there 200, but you put it here 150.
Yes, so it's less.
Yeah.
That is AVG, this is AVF. If that AVG is not available, this will force to become AVG. Preempt. Okay, preempt. Enter, and that's all I need to do here. You can still do here also the hello times and that everything you can set here also. And router 4, conf T, interface FA0 by 0 and say GLBP 1 IP 192.168.1.254, enter, GLBP 1, priority of this is, let's say 120, okay, which is again less than that. Yeah, and GLBP 1 and preempt, enter. So that's all I need to do for this. Okay, let's see where the traffic is going. I will show you router 1, sorry, router 2. Router 2 is this router, okay, which is our AVG now. And let's see what it shows in show GLBP. Enter. See, I told you that still it will show us the status of active, but actually it is our AVG. Okay, let's see if it is written somewhere. It's not written anywhere. Brief. AVG. It's not written anywhere, but still it's going to be our AVG. Okay.
It's written there. What's that?
Where?
Freeman there. I can't see Freeman there. 1, 2, 3. What's that? There's 3 sections.
This one?
No, on the top.
Okay. Yes. Sorry. Yeah. So you see, it says there are 3 forwarders. Okay. And this is forwarder 1 is actually this one. Okay, with MAC address of this. Okay, it's and forwarder 2 is with MAC address of this. Okay, now here actually we can see how from where the data is going. Let's check it from R1. So I can use here trace route 10.0.0.1. let's see. You see, it's using that first router. Okay, it's using that first router, this router, and I'm gonna give ping 10.0.0.1 and repeat sorry, what's going on? Repeat. This should be selected and then right click. Okay, so is the spelling right?
System much.
T.
PEAT. Repeat.
What's going on? Repeat. Okay, and now okay, enter. So let's see, we have pings are going on, traffic is going on. We'll go to router 2 and try to shut down that interface FA 0 by 0 and say shut. Okay, I want to see that immediately. I just want to see that immediately. You see, there is one drop. Yeah, it's taking some time to move its traffic. See, now it started. So at least it's doing automatic, and at least it's doing everything itself. Now if I see R2, R3 should become now the active or the first forwarder 3. Show GLBP. You see here it says that I am now active. Okay, and I am the first one. Okay, and I'm using, this is my virtual IP, okay, it's my property for now. um, so that's all. Any confusion in this? If this one is again coming online, so no, shut, this will become now, see, these are statuses.
Show me the things, sir.
Yes. Huh?
Show me the pen. PC.
Yes, pen PC. Now it found it. See? So this is how it works. Any confusion? GLBP, gateway load balancing. Any confusion, any problem?
The configuration which just comes from one router to another router, that's called load balancing.
No.
So then
We didn't do anything new, it's like same.